So we're talking linear functions, and we're looking at the various transformations you can do to linear functions. And in this video, we will focus on vertical shrinks and stretches. And as I included in the background to the other videos on these transformations, the idea is that we're taking a parent function, f of x, and we're transforming it to get a full family of functions. And we're currently talking about linear functions, but f of x can really be any kind of well-behaved function. So the rules here for how we do shrinks and stretches apply not only to linear functions, but to any function. So what are vertical stretches and shrinks? Well, vertical stretches and shrinks are transformations where we multiply the y-coordinate, which is our entire function really, right? It's our outputs. We multiply by a number a. And here again, a is a constant. It's not a variable, it's a number. So whenever we do this transformation, we use the same a for the entire graph. If we have a larger than 1, we will get what we call a stretch. And if we have a between 0 and 1, which means a fraction, we will get a shrink. So what do these two transformations look like? Well, here on the left, we have our original function here in red, f of x equals x plus 2. Now, when we do the stretch, we're going to use an a that is larger than 1. I took here a equals 2. So I'm multiplying, and let's actually not call that f of x, but h of x. We multiply the entire function by 2. So what happens when we do that? Well, let's look, for instance, at the point here. We have the point 0, 2 in our original function. When we multiply it by 2, we go up to 4, right? What happens with this point here? We have the point, this is 3 and 5, right? X equals 3, y equals 5. When we multiply our entire function by 2, we go straight up to 10, right? So basically what we're doing is we're shifting this whole function, this whole red graph, up to the blue one. But we're not just moving it up rigidly, we're basically spinning it, and we're spinning it around our x-intercept, which is the point on the graph where y equals 0. So when we had horizontal shrinks and stretches, we were looking at these spins that were about the y-intercept. Here, we're looking at spins that are around the x-intercept. So again, when we use an a that is larger than 1, like this case, we call it a stretch because basically we're stretching the graph up the y-axis, vertically upwards. What happens when we take a that is a fraction, like in this case, a equals 0.5 or a half? In this case, let's look at those same points. Let's look at 0. Well, when x equals 0, instead of getting 2, like we have from our first function, from our original function, we'll change this to g of x, what we get is half of 2, so we get 1. So we've moved downwards. What happens at 5? So we had here 5 and 7. Well, if we take 5 and we add 2 to it, that's 7. Half of that is just 3.5, which is right here. So we move down this way. So in this case, our graph spins again around our x-intercept, but it spins downward this time, so we call it a vertical shrink. It's like our entire graph is shrinking towards the 0 of the y-axis. In the stretch case, our graph is stretching towards the y-axis or away, shrinking away from the x-axis. And as I also emphasized in the horizontal shrinks and stretches video, there's an equivalency. When we apply a vertical stretch, it is somewhat similar to a horizontal shrink. When we apply a vertical shrink, it is somewhat equivalent to a horizontal stretch. They are not exactly the same because, again, here we are spinning around our x-intercept, while in the case of a horizontal stretch or shrink, the spinning is around the y-intercept. So this is the end of the video about vertical shrinks and stretches. If this whole set of videos was helpful to you, please like. And if you haven't seen the other videos on the transformations of linear functions, please check out the playlist, and I hope they'll be helpful. Okay, I will see you again next time.